This is an amazing shot that was taken from my good friend Ben Canals, and it's just one of those kind of views that you stand out there and you look up into the Milky Way. It's just a fabulous picture. And I'm going to talk a little bit about the Milky Way, our home galaxy. The Earth and its solar system orbit within a formation of stars that we call the Milky Way galaxy, one of the many billions of galaxies thought to exist in our universe. Our galaxy formed some 13.5 billion years ago, soon after the Big Bang. The Milky Way is believed to harbor as many as 400 billion stars and at least as many planets. To the naked eye, the Milky Way appears as a faint band of light in the night sky. The exact layout of our galaxy is difficult to determine from our position embedded within the main disk. It's currently believed that the Milky Way had two primary spiral arms that emerges from the central bar, in addition to other minor arms and spurs. The arms are thought to be a pattern of density wave that travels around the galaxy as it rotates. At the center, the galaxy harbors a huge black hole with more than 4 million times the mass of our Sun. We orbit approximately 27,000 light years from the central black hole. So the question is, when we take a look at the Milky Way, what does it look like? How do we know so much about the Milky Way already? And so we take the image here, we can clearly see that we're within the plane inside of the Milky Way. So there's a few facts that we know. That it's a bar spiral. And the diameter of the Milky Way is about 100,000 light years across. And the mass contains 400 to 800 billion solar masses and at least 400 billion stars. And we're in the local group within the Virgo. Okay? So the question is, what does our galaxy look like? Okay? So let me show you this awesome website that you can go to, the Chrome Experiment. And you can actually interact with it so you can get an idea kind of our scale of our Milky Way. So you can move this bar up and down. So here's the view from outside of our galaxy, and you can zoom in on it a little bit. This is real time. So you can, this is actually works pretty well. So you can zoom in. Now you can see our local stars. Okay? And so when you think about all the constellations that we know of, 88 constellations, these are the bright stars. So we can only see the stars within our galaxy. And so we can zoom in even more, and then you start seeing some of the recognizable names of our stars. Right? But keep in mind that this is only a few light years away from our own Sun. Okay? So as you back up just a tiny bit, there's Sirius right there, and there's Altair, and some of the recognizable stars. Okay? And so this is what we see in our current night sky. So you continue to zoom in. Now we see the Oort clouds. It's about 1 light years away, which means about 6 trillion miles. Right? And so as you continue to zoom in, that's where all the comets live. It's in the Oort clouds. and they're way outside the orbit of Pluto. And then that small dot right there is our sun. Can you believe that? And then if we get closer, now we start seeing the solar system, and there's the planets, right? But the sun is still a tiny little star. And there's home Earth, the inner planets. And then we arrive at our sun, right? So that's a sense of scale that we're quite tiny compared to the scale of the Milky Way. And it gives you kind of perspective. So this is kind of the view that we have right now. That here is the bar. This is why it's called bar spiral galaxy. There's the Sagittarius arm, the Perseus arm, Orion. There's our sun, right there. Then we're about 27,000 light years away from the center, right? And so when we look up at the Milky Way, we see what appear to be the two main spiral arms. Okay? And the name that you're seeing here associate the constellation in the line of sight. There's Orion's bird, there's the Perseus arm, there's the Centauri's arm. Okay, so these are called a spiral arm. Now keep in mind, this is about 100,000 light years across, and then we're about 30,000 light years away from the center. Okay, so there's a side profile. And there's some definition involved with the profile of the Milky Way. It is 100,000 light years across. It's only 1,000 light years thick, very thin. Okay? And then we have our location about 28,000 light years away from the center, and this is called the disk. And then surrounding the center is called the bulge. Right? And then we have the halo, which we're seeing that goes on indefinitely surrounding the galaxy. Okay? And then we have the globular clusters that orbit around the center. And our own solar system travels roughly at about the speed of 515,000 miles per hour. So taking that speed, it will take 230 million years to get all the way around the Milky Way. That was a fun video. They could actually go to the NASA website and get that particular video, and it shows kind of the scale. Right? So when you look at the nighttime sky, when you look toward the constellation of Sagittarius and Scorpion, right at that window right there is the center of our Milky Way. Right? And so you wouldn't even notice by looking at that in that view. Right? So the way that scientists are able to see the center is to look at a different wavelength. So if we go up and down the scale, look at all the visible wavelengths, gamma, X-ray, there's the visible, that's what we see. But then you get into hydrogen, now you're starting to see the intensity and where the center, so just by looking at this, you can clearly see even in and far infrared, microwave, and then go down to the hydrogen, and then the radio. Right? So just by looking at this, you can clearly see how the energy source is coming from the center. And this is our visible light, but this is the way to look at the Milky Way. Okay? So here's take a view toward the center. Believe it or not, that's actual data. This is from the European Space Observatory. And there in the center, what you see is the black hole. And we see those stars are orbiting around what appears to be the actual black hole. So they speed up as they orbit around the center. We can't see it per se, but we know it's there. And someday, if we get the new horizon, that we'll be able to get a picture of the center of our Milky Way. And then billions of years from now, this is kind of a view that we will have of our nighttime sky. The Milky Way and the Andromeda Galaxy are on a collision course. And then, in the future, this will be our view. And it seems to be transparent, but the sky will never look the same again. And all the stars are in motion, and the galaxy merge, and to have an incredible view of the nighttime sky. Of course, by then, the Earth may be gone because of the expansion of the sun becoming a red star and then planetary nebula. Right? And so that's kind of a view that we see in the future of our Milky Way, our home.